Okay, you guys, this is our last practice problem for the beginning of class, so let's see how we did. All right, hopefully you ended up with an answer of negative 1.13, but let's take a look at the question first. Okay, so this one, first thing again, we always want to figure out what kind of a collision are we talking about? And so we got this football player, and so he's going this way to the north, and there's another football player heading to the south, and then they collide, and the first football player keeps going. All right, so we should really say like 1 and 2. All right, so player number 1 keeps on trucking. Up he goes. All right, he's got a slower velocity, and we want to figure out what happens to guy number 2. Okay, that is probably arguably one of the worst diagrams I've ever drawn, but hopefully it makes a little bit of sense. Good grief. I hope nobody looks for that online. Anyway, we've got two objects that move and they bounce off each other. That, lo and behold, is what we call an elastic collision. All right, so let's see how this works out. If you did it with a chart, we'll start with that. You know, we love our charts in physics class, right? So they definitely help us get going. So, all right, let's consider, let's see, before, after, right? And we've got football player 1, and we've got football player 2, and we've got the total. All right, give myself a little bit of room to work. Nice job. Okay, so my first football player is 92 kilograms, and he's moving with a speed of 6.5 meters per second. So when I do the math there, I get 598 kilograms meters per second. Okay, my second guy, he's headed to the south, and he is 85 kilograms. And he is moving 6 meters per second south. I would make that negative because that is the standard for physics class, right? Left and south are considered negative, just like a Cartesian plane. So negative 510 kilograms meters per second. Okay, when I add that together, I guess technically I'm subtracting, right? But I get a total of 88, which I know has to be conserved because good gravy, we've been doing this for forever now, and we are smart. So we know that this is the case all the time. All right, we're going to conserve it within this system. So let's see what else they're telling us in this question. It says the 92 kilogram football players, that's player A, right? So the 92 kilogram player, he continues moving at a velocity of 2 meters per second after the collision. So if he is continuing, he is still going to the north. It's just, you know, slower. Right? So we've got 92 times 2, which is 184 kilograms meters per second. And we want to know what happened to the 85 kilogram guy. So that's the velocity. Whoops, I was about to write kg, and I should, but oh, I ruined my pretty chart. Oh no. All right, that's okay. I think we can handle it. All right, but let's just put it in that variable v. All right, now, as you've kind of seen as we go along here, right, this momentum plus this momentum equals the momentum at the bottom. It equals the 88. So then we can actually look at it like an algebra equation and say, all right, 184 plus 85v equals 88. I'm going to move the 184 over. I am almost out of room, so I guess I'll have to go to the other side a little bit. It's okay. I was going to redo the whole thing together as an equation, but I'll just have to erase. Not a biggie. Oh, I already did that part. Here I am redoing the same stuff I've already done over here. Okay, so we've got 184 plus the 85 equals 88. We're going to subtract the 84 from both sides and then do a little bit of math. We do get a negative answer. It should be negative, right? Follow the algebra. If the algebra gives you a negative answer, keep it. Don't just try to manipulate it thinking, oh, well, he should still be going forward. He's hanging onto the guy's arm or whatever. Let the algebra tell you the direction. That's where it is. All right, so there's your chart. If that is not how you solved it, if you are a straight algebra traditionalist, like I tend to be, let's give myself a little bit of room here. we will see a lot of the same numbers. However, we tend to set it up a little bit differently if we do it with straight algebra. All right, so what we would say there is then, we'll just say 1. My first player, my second player, right? They have different initial velocities, should be equal to m1 vf1 plus m2 vf2. That's the straight algebra solution. At this point, you kind of plug in your variables. So 92 kilograms. I'm going to drop the units just to give myself some space. He's running 6.5 meters north. He's going to collide with that 85 kilogram player, and he is moving to the south, so we got to know to put it in as a -6. My 92 kilogram player then again is moving at what? I blocked my own view here, 2 meters per second plus the 85V. Right, so if I do that, this is -510, this is 598 equals 184 plus. Okay, so I'm going to combine this, of course. Now it's starting to look pretty, well, that's supposed to be an 8. That's terrible. All right, this should be looking pretty familiar. So I end up with, again, 85V equals -96, V equals -1.13 meters per second. Regardless of how you solve it, show your work, label your answers, and I will see you soon.